Good morning, good afternoon, and good evening. Welcome to none other than the Crazy Hat Chemist. So today here we're going to be doing a very short video on my homemade stoichiometry flow chart. Okay, so that's what we're going to be discussing today, the stoichiometry flow chart. All right, awesome. So on the far left-hand end is mass, and then right here is mole, right here is molecules, here is atoms, and here is volume. So, and then we have some unit conversions of which we'll go over here in just a moment. So, mass. What would be the units of mass? Well, the units for mass for us would be grams. And that's designated as a lowercase g for grams. Okay. And then what is very, very important here is that this section here that is the mole. This is the amount of substance. So how much do you have? That would be a mole. And what's the number in front of the mole? Oh, yes, that's right. It's a 1. So that means that the mass in grams is equal to 1 mole. And what we use is called the molar mass, and I'll discuss that in just a moment. That means that 1 mole is equal to the mass in grams. 1 mole is also equal to 22.414 liters. Liters is a volume, and this only occurs with gases at STP. So standard temperature and pressure, okay? Standard temperature and pressure, 1 mole of any gas is equal to 22.414 liters. That's a volume. 1 mole is equal to Avogadro's number. This is Avogadro's number, 6.022 times 10 to the 23rd molecules. So 1 mole is equal to Avogadro's number, that is 6.022 times 10 to the 23rd molecules. Then if we continue on this journey here, then we will have molecules, and then we will have atoms. So 1 molecule, and this is a counting number, is equal to a counted number of atoms. Okay, so this is our flow chart. We will not be discussing this mole ratio here right now. That will be for another day, so I'm going to leave that for another day. Okay, so what we're going to do is we're going to discuss a few other things. Before we do that, though, I am going to give you some examples within here so that you can tie this into some, hopefully, information that you already know. So it says 1 mole. So let's just pretend that this is $1. I am in the United States, so that's $1. Okay, $1 is equal to a number of different things. Okay, so $1 is equal to, well, let's say 10 dimes. $1 is equal to 10 dimes. This is a unit conversion. $1 and 10 dimes is equal to 20 nickels. Then $1 is also equal to 100 pennies. $1 is equal to 4 quarters. So that means that $1 is equal to 4 quarters. $1 is equal to 100 pennies. $1 is equal to 10 dimes. $1 is equal to 20 nickels. 20 nickels is equal to 10 dimes. 10 dimes is equal to $1. $1 is equal to 100 pennies. These are all equivalencies here. So that means that 1 mole is equal to the molar mass in grams. 1 mole is equal to 22.414 liters of any gas at STP conditions. 1 mole is equal to Avogadro's number, that's 6.022 times 10 to the 23rd molecules. And 1 molecule is equal to a counting number of atoms. Okay? All right, hopefully that makes sense. That will give you a real world example. What we're going to do is we're going to slide this up a bit so that we have a certain section here. Okay, and we're gonna bring these babies down to hold this down. All right, perfecto. All right, so now we're gonna discuss the unit conversions. So the unit conversions are right here down at the bottom. Unit conversions. We're gonna be taking advantage of these unit conversions. But before we get into those unit conversions, we need a quick little advertisement from our sponsor. Boosh, 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 boosh. That's right, folks. Today's sponsor to today's video is none other than me, myself, and I. That is the Crazy Hat Chemist. Please like, subscribe, watch my videos, and give me some comments. Okay, I do answer my comments when they do come in, and the comment section is out of control, so you'll have to wait until I get to those comment sections because it is truly out of control with those comments. Thank you very much. All right, so let's continue here. We're going to slide this all the way up so that we're looking at just the section that we are looking for and needing here at this moment in time. All right, so what we've got here is the following. 1 mole is equal to the molar mass in grams. So an example of that being, here's an example of this, 1 mole of carbon, okay, is equal to what? 12.01 grams of carbon. Okay, and so what we're going to do is we're going to find on our periodic table where carbon is, and carbon is right here. It is element number 6. It is carbon, and what's the number? 12.01. So that's right. That's why 1 mole of carbon is equal to 12.01 grams of carbon. I'm going to give you another, that's an element example. Now I'm going to give you an example dealing with a compound. 1 mole of water is equal to 18.02 grams of water. Now the question is, how did we come up with this value of 18.02? What we're going to do is look at the formula of water. It's H2O. We're going to find both of these elements. That is hydrogen. That's atomic number 1. Its molar mass is 1.01. So the molar mass for hydrogen is 1.01. That's for hydrogen. And how many hydrogens are there in this formula? 2. So I'm going to multiply this number by 2. Then I'm going to find oxygen. That is the other element that's in water. And oxygen is atomic number 8. It's O. It's oxygen. Its molar mass is 16.00. So 16.00. And how many oxygens are there? There's 1 oxygen. So what we're going to do is do the 2 times 1.001 plus 1 times 16.00, and that's why we get 18.02. We're actually rounding this to the fewest number of decimal places, which is 2 in this case. All right, cool. Let's go to the next one. 1 mole is equal to Avogadro's number of molecules, and that's 6.022 times 10 to the 23rd. So here's an example. 1 mole of water is equal to 6.022 times 10 to the 23rd molecules. Okay, all right. By the way, you should see that 1 mole is equal to the molar mass. 1 mole is equal to the molar mass. That's right there. Also, 1 mole is equal to Avogadro's number of molecules. 1 mole is equal to Avogadro's number of molecules. Okay. Our next one is 1 mole, again, is equal to 22.414 liters of any gas at standard temperature and pressure. So 1 mole is equal to 22.414 liters of any gas at STP. And that is 1 mole of hydrogen gas is equal to 22.414 liters of hydrogen gas at STP conditions. Okay, it's very important that this is STP conditions. It does not apply to any other set of conditions besides STP. And then what is standard temperature and pressure? So standard temperature is 273.15 Kelvin, and the standard pressure is 100 kilopascals. And for most intents and purposes, most chemistry teachers, instructors, textbooks say that the standard pressure is actually 1 atmosphere. 100 kilopascals is actually the true value, but it's really close to 1 atmosphere. So for all intents and purposes, it's just fine. All right. So then our next one is, I want you to notice that thus far on our unit conversions, I've had 1 mole of everything, and then that is equal to either the molar mass in grams, Avogadro's number of molecules, 22.414 liters of a gas at STP conditions. Now we're going to change this up. We're going to say that 1 molecule is equal to a counting number of atoms. So this is very critical that you understand this. I got 2 examples here at this. 1 molecule of water is equal to, we're going to look at how many of each element is in this formula. So there are 2 hydrogens, so that's why there are 2 hydrogen atoms. There's 1 oxygen, there's 1 oxygen, and 2 plus 1, that's a total of 3 atoms total. Second example is for calcium hydroxide. 1 molecule of calcium hydroxide has the formula CaOH parentheses 2. There is 1 atom of calcium. There are 2 atoms of oxygen because that 2 distributes of what's that 2 is like a mathematical problem right there. It's a number outside the parentheses and you distribute it over all the terms inside. And then you have 2 atoms of hydrogen. 1 plus 2 plus 2, that's a total of 5 atoms. All right, so folks, you are going to be using this flow chart. It's a very important flow chart of stoichiometry to go transfer from one set of units to another set of units. And how do you transfer from one set of units to another set of units? You're going to be using unit conversions, just like you have dollars, quarters, pennies, dimes, and nickels. I hope you've enjoyed that video. It's been a short little video, but please like and subscribe. I love you very much and enjoy your day. So long, farewell, auf Wiedersehen, goodbye.